Screen is visible? Okay. Wait for a few minutes, huh? Wait for a few seconds. So today we are going to discuss about the array codes. So last class we are discussing about the BCD code. BCD code also called a non-weighted binary code. Okay, and gray code also we can say that it is non-weighted binary code because we are not generally using the weight. Okay, so suppose weight means what? Suppose 2 or something. Okay. So similarly, in the BCD code, another non-weighted code is called a gray code. Okay, and where if we are using the gray code, then always remember when successive code words differ in only one bit. Are you hearing me now? Are you hearing me?
Yes, sir. Yes, sir. Yes, sir.
Yes. Successive code words differ in only one bit. Then always remember when we are constructing the gray code, that means what? The successive code means what? The neighboring codes. Okay, that means one particular, suppose you know when we are writing the binary code, there are some particular slots are there. Okay, you can start from LSB also, you can start from MSB also. Okay, but you know how to, if we are going the LSB to the MSB, then how weight are coming. But when we are talking about the gray code, that means generally what happened, this is the non-weighted code, and generally we are starting from MSB to the LSB. Okay, and also some particular, when we are constructing the gray code or generating the gray code, that time when some particular special properties are given, that means some particular special property actually it is established through the by the gray codes. Okay, one particular special property is called a cyclic code. This one is called a cyclic code because what happened? Why it is called a cyclic? Because what happened after, if when we are generating the, I'm just discussing. After a few slides, I'm discussing why it is called a cyclic code, because some codes again we are repeating to construct the another code. Okay, another gray code. Okay, or another gray sequence. Okay, so what happened? One particular special property is called a cyclic code. Okay, and this particular point always you remember when we are constructing the gray code. That time what happened? Where successive code words differ in only one bit. This is very important point. Differ only one bit, not more than one bit. Okay. So what happened? So generally what happened? Every sequence generating some type of unique sequence. Okay, it is not repeating. So what happened? We can, based on that particular unique sequence, we can know that yes, this particular decimal number is 2, then this is the gray code. This is the sequence of gray code. And every gray code corresponding to their binary code. Okay. So based on that binary code and gray code, we can easily know that what is the gray code of this particular binary code, or what is the this is the gray code and the corresponding binary code is this one. Okay. Generally, what happened? This particular code, some type of special conversion we are using. That means what? Gray code is useful in many practical applications that is required to analog to digital conversion. It is very important, analog to digital conversion. So that means what? Analog to digital. Why it is we are calling to analog to digital? Because what happened? Analog means what? Digital means, analog to digital means what? Some particular continuous events is occurred. Suppose what happened? Continuous events means what? Suppose we are going from 1 to 7. So what happened? It is not jumping from 1 to 3. Okay. 1 to 7 means what? It is coming 1, after 1 it is coming 2, after 2 it is coming. So continuous, some particular continuous events are occurred. When we are talking about some particular continuous events, that time what happened? This particular gray code is very useful in practical application. Okay. Moreover, so when we are using the gray code, that time also what happened? This particular gray code generally we are sometimes some particular applications we are using as a reduce error in conversion. I'll discuss later why it is called a reduce error in conversion. That means what? Some particular errors are minimized if we are using the gray code. Okay. So, or maybe some particular conversion process we have established using this particular gray code such that it is reduce the error. Okay. And also what happened? It is very easy when we are converting to binary to gray code. Okay. And gray to binary conversion. It is very easy. So this particular example we'll discuss later actually. Suppose what happened? Some particular analog rotation of a wheel. It is the good example of gray code. Okay. So after this one, see here the first table. So it is just converting binary code to gray code, and second table we are converting from binary code to gray code. See here, if we are considering this particular, if we are talking about the only gray code, that time what happens? See here, first sequence 0 0. That means it is bit. We are starting from G0, G1, G2, and G3 from LSB to MSB. Okay, from LSB to MSB we are considering. So see here, if we are considering this particular two sequence, okay, this particular two sequence, that time here, what happens? See here, the first sequence it is 0 0 0, and second sequence is 0 0 0 1. Okay, so first bit what happened? Only one bit is differed. Okay, 0 and 1. Suppose if you are considering this particular next two bit sequence, if we are considering, that time what happens? See here, 1 1 is same. The G2 of both the sequence 0 0 is same, and G3 also both the 0 0 is same. But G1, see here, only one bit is different. So every code when we are comparing in sequence manner, I'm not talking about the for jumping, you are directly going to the 0 to 7, 5. If you are comparing, then it is not possible. But when we are going from sequence wise, that time what happens? You can say that all the bit sequence are differ only one bit. Okay, that is the special properties of gray code. Based on that, what happened? Some particular unique gray code is generated by the binary code, or you can say vice versa. From the binary code, you can generate the unique gray code. Okay, so just I am showing this one is the first table. It is showing that binary code to gray code, and second table it is showing that binary code to gray code. Okay, So any doubt this one? This one is okay, na? This one is okay?
Yes, sir.
Next, see here. Next what? Gray code is also called a self-reflecting code. Okay. Earlier what happened? It is cyclic code. Earlier what happened? It is called as cyclic. Just a minute. Just a minute. Just a minute. हेलो बोलिए क्या बात है थोड़ा मैं बाद में जाऊंगा थोड़ा मैं ये हूँ अभी के ये चल रहा है क्लास चल रहा है थोड़ा देर के बाद जाऊंगा ठीक है आप शुरू कर सकते हैं कोई प्रॉब्लम आप लोग जा सकते हैं नहीं तो उसका टाइम हो जाएगा तो वो चला जाएगा ठीक ठीक so earlier what happened gray code property is called as cyclic code okay this is the one cyclic code means what some cyclic rotation is going on when we are constructing the gray code this is the one property also another property is called a reflecting code self-reflecting code not only reflecting code this one is very important someone is asking you which particular code is behave like as a self-reflecting code then your answer is gray code your answer is gray code okay this one your answer so what happened suppose we have the gray code representation from m bits okay gray code representation for m bits m is any number maybe 2 maybe 3 maybe 4 whatever the number to next point C to obtain the gray code representation for m plus 1 bits we write down 2 m bit representation one below the other okay see here we are obtaining the gray code representation for m plus 1 bits okay we write down 2 m bit representation one below the other okay one below the other with the second one being the mirror image of the first one okay see here how this one is actually working so what I can see here the first in this particular see here carefully in this particular portion at first very carefully in this particular portion so how many bit sequence are there only 2 bit sequence are there so we are writing from 0 to 3 this one is 0 0 this one is 0 1 this one is 1 1 and this one is 0 0 1 0 and this one we are considering as a what m bit so here what happened m equal to we can say that m equal to here what 2 we can say that m equal to 2 okay now what happened if you are interested to construct the m plus 1 bits that time what happened same thing we are repeating 0 0 also here we are writing 0 1 also here we are writing and 1 1 also we are writing and 1 0 just we are copy this one to this one okay this one to this one so m plus 1 bits means what now we are extending 1 bit to the MSB side so this one is 0 0 so when we are constructing this particular one this one is now what happened this one is making as a this particular whole portion is constructing as a m plus 1 bit this one is called a m plus 1 bit okay so this one is the m plus 1 bit okay now see here we are just writing the mirror image so mirror image see here the first statement is in the second statement is says that the mirror image of the first one so what happened so we are when we are the bottom is the first above the straight line the first from the bottom 1 0 this one is the first bottom sequence last sequence but when we are writing the another sequence so what happened this particular 1 0 is moving here we are doing nothing. Just we can just this is the, so it is called a mirror image. So 1 1 we are writing here, okay, and 0 1 we are writing here, and 0 0 we are writing here, and all the this particular MSB bit, all the zeros we are converting to the 1. So what happened? From this way we can getting the m+1 bits. Again, what happened if when you are writing, just a minute. Hello? So what happened? Next, so what happened? This way, now what happened? Here, this is the m+1 corresponding to this particular m bit. Now what happened? Again, you can extending this one. So this one, what happened here? Again, I'm writing this one. Okay. So what happened here? Again, you can write 0 0, all are 0 up to this one. Up to you can write here 0, here 0, here 0. Again, you can starting from the 1 1 0 0, 1 0 1, 1 1 1 1. So you can just, it is the why, that is why it is called a self-reflecting code. So this way, what happened, from any m numbers you can converting to the m+1 bit. That is the specialty of gray code. So it is called a self-reflecting code. Okay, so see here, third point, when then add a 0 at the beginning of every code in the first group. So this one is the first group. We are considering this one is the first group. Okay, so this one is the first group. So next one is the what? The mirror image for m bits. And after that, what happens? You can directly add the 1. So that is why it is saying that, and 1 at the beginning of every code in the second group. So this one is the first group above the straight line. This one is the first group, and after the straight line, this one is called a second group. So it is called a self-reflecting gray code representation or generation. Okay. Any doubt this one? Are you getting this one?
Yes,
Are you getting this?
yes,
Okay.
Sir,
So if any doubt, then please ask me. Don't hesitate. Yes, please.
सर सेकंड में जो मिरर हुआ है ना, जो 1 1 1 1 है, उसको फिर से मिरर करने से क्या 0 आएगा कि 1 ही रहेगा वो फर्स्ट मोस्ट सिग्निफिकेंट बिट्स में?
अच्छा, ये जस्ट मिनट, क्या बोल रहे हैं मुझे, जस्ट मिनट. क्या बोले? अच्छा, यहाँ पे यही पूछ रहे ना? अभी क्या होगा, ये तुम्हारा क्या हो जाएगा, ये पार्ट, जो ये पार्ट है ना, ये पार्ट तुम्हारा फर्स्ट ग्रुप हो जाएगा, ठीक है? और इसमें क्या होगा, इसमें पूरा 0 टू कहाँ आएगा, सब में 0 होगा, ठीक है? 0 0 सब में 0 आएगा, यहाँ तक क्या आएगा, लास्ट तक 0 आएगा, ठीक है?
अच्छा.
और अभी नेक्स्ट पार्ट में क्या होगा, नेक्स्ट ग्रुप में क्या होगा, ये तुम नेक्स्ट ग्रुप में क्या होगा, ये पहले कहाँ पे एंडिंग कहाँ पे हुआ हम लोग का 1 0 0 में हुआ, ये वाला में एंडिंग हुआ, ठीक है? इसको क्या होगा, हम लोग यहाँ पे लिखेंगे 1 0 0 और इसमें क्या लिखेंगे, हम 1 लिखेंगे. अभी क्या होगा, इसमें सब में 1 होगा.
अच्छा, वो पूरा एक ग्रुप बन जाएगा.
हाँ, पूरा एक ग्रुप बन जाएगा. सो तो नेक्स्ट में क्या आएगा, नेक्स्ट ये वाला पार्ट आ जाएगा, ये वाला पार्ट आएगा, क्या आएगा इसमें 1 0 1. दैट इज द ब्यूटी ऑफ ग्रे कोड. सो क्या है आपका, अभी m, आप बोलिए इस पर्टिकुलर का मैं फर्स्ट ग्रुप को कंसीडर करूंगा, इसमें m का वैल्यू क्या है, इसमें अभी m का वैल्यू मेरा है 3, ठीक है? तो m का वैल्यू मेरा क्या है, 3 है राइट नाउ. तो ये जो MSB में मैं जब 0 0 यूज करूंगा, तो इसका m का वैल्यू क्या हो गया, m+1 बिट, एक बिट जोड़ गया, तो इसीलिए हम लोग बोलते हैं m+1 बिट. सो इसमें m का वैल्यू क्या था, पहले 3 था, और 1 ऐड करने के बाद क्या हो गया, 4 हो गया. तो हाउ मेनी बिट्स आर देयर, 4 bits are there. Are you getting my point? So yes, for a particular purpose, a gray code also it is called a self-reflecting. If someone is asking you why gray code behave like as a self-reflecting, then you can just see, tell this particular concept. Okay, it is clear, everyone? It is clear to everyone?
Yes, 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 sir.
Yes.
Now what happened? Just earlier what happened, we can just see this particular table. Okay, this particular table we are considering this particular one. This particular one is means what? We are converting binary code to gray code. Okay, and second table we are converting. Here I'm writing same thing. It is binary code. Maybe it is gray code. Okay, no problem. Here this one is maybe gray code to binary code, but no problem. You can construct yourself this particular table. This one is okay, binary code to gray code, and this one maybe instead of binary code, here I am writing gray code, but similar. Okay. Now what happened? How we can construct this particular table? How, that means my question is that how we are converting binary to gray or gray to binary. Okay. So some particular rules we have to follow when we are converting. At first we are considering binary to gray code conversion. And remember, so this particular concept also required when you are designing the combinational circuit or sequential circuit. So this particular conversion process, your concept must be clear. Otherwise, whatever, you cannot design the combinational circuit or whatever the circuit. Okay. So whatever we are discussing till now, up to, because I have completed more than 5 class hours. So every concept must be cleared. Because this particular concept also used in when you are designing the circuit. Okay. It is not like the numbering system something different from the digital circuit. Numbering system is very essential. Very, without numbering system, we cannot design any digital circuit. Okay. So what happens, see here, suppose we are representing gray code this particular fashion. This is the binary sequence, normal binary sequence. G and, because I am using, suppose why I am using G and B, because this one it is representing as a binary code, gray code, and this one Bn-1 to B0 we are using as a what? We are using as a what?
Gray code.
Yes, binary code. So what happened? Gn-1, Gn-2 up to G0, it is behave like as a gray code, and Bn-1 to B0, it is behave like as a binary code. Okay. Now what happened? We can see how we can convert from binary to gray code conversion. This is called a binary to gray code conversion. So we can follow the first rule. I am writing in the expression format. You can check, or because if you are going to the many books, there are different particular rules are there. But these particular rules you have to follow. Otherwise, some particular different rules are also there, but you can use only one rule when you are converting binary to gray. Though you know 2 and 3 rules, always use only one rule. Otherwise, whatever, you can confuse. Oh, okay. So what happens? See here Gi, I may be what? I may be 0 and -2. Are you getting my point? Now what happens? You can ask me, the range is n-1 to G0, or here G0. Why this particular I range is 0 to n-2? Why it is not an n-1? Can you tell me? Anyone can tell this particular answer? My question is that the range of the gray code sequence from the MSB to the LSB, the range is n-1 to 0. Okay, no problem. If you are normally, when we are constructing the binary sequence, that time what happens? G0, G1, G2, we are writing from LSB to MSB. Okay, fine. Now what happened? What this particular expression I will explain later. Okay, you don't worry about this one. But why I am writing, that means what? Here, oh sorry, this one is, sorry, here some problem is coming. Okay, just a minute. Okay, so my question is that why I range is, this particular I range is y0 to n-2. Why we are not writing n-1? Anyone can tell me?
So it is because of the expression that the expression says bi some symbol and then bi plus 1. So if I plus 1 we put n-2, then we get the range up to n-1.
Because see here, if there are 5 numbers, suppose here I'm using suppose n minus 1 is 5 and G0 is suppose we are G0 to G4, suppose. G0 to who is in the A? Who is this one? Kingsley Basin. It is your student? Kingsley?
Yes, sir. Yes,
Huh?
sir. Yes, sir.
See, actually, if there are 5 gray bits, 5 number of gray bits, that time what happened? Here already GI is already used. One particular bit already used. So now what happened? What is the range? Range we are going to n minus 2. Okay. So what happened? We are talking about the total numbers. Suppose here what happened? Here if the cardinality is 5. Suppose this one cardinality is 5. Okay. Cardinality is suppose 5. We are using the 5 bits. If already one particular bit is already using here, GI, that means how many bits are remaining left? Only 4. So what happened? If we are writing n minus 1, that time what happened? The 1 bit is extra is coming. To maintain this particular one, here we are writing n minus 2. It is just simple. It is normal mathematics. Okay. So what happened? When we are converting binary to gray, that time what happened? We can use this particular one. Suppose what happened here, this one binary, this one, how we are getting the gray code? Gray code we are using this particular form. BI, and this one is the modulo 2 operation. Right now you can think that this one is the modulo 2 operation. Don't use the XOR gate or something like that. Just we are saying that this particular symbol behave like as a modulo 2 operation. And after that, what happened? BI modulo 2 operation, BI plus 1. Okay. That time what happened? Whatever the bits are generated, we can insert GI. Okay. And Gn minus 1 equal to Gn minus 1. So that means what? Which one is the Gn minus 1? Always MSB bit is called a Gn minus 1. MSB bit we are saying as a what? Saying as a Gn minus 1. Are you getting? So see here, this particular one symbol is denoted as a modulo 2 sum operation. Now what happened? How modulo 2 is behave like that? If we are using modulo 2 between the 0 and 0, the output is always 0. When we are using the modulo 2 operation between 0 and 1, the output is always 1. Okay. Till now, we are not going to the logic gates and all those things, so I am not using the term XOR operation. Okay. In this particular symbol also in logic gate, it is behave like as a XOR gate, or also it is called a XOR gate. Okay. This one is called a XOR gate. Okay. But for time being, you just consider this one is the modulo 2 operation. And when we are using the modulo 2 operation between 1 and 0, the output is 1. And when we are using the modulo 2 operation between 1, 1, then output is always 0. Okay. Now suppose what happened, we are interested to convert this particular binary code to the gray code. So how we are converting? See here, which one is the n minus 1? What is the value of Gn minus 1? Gn minus 1 value of binary code is 1. So just we can copy this one in gray code. That means similar. We are not changing anything. Just we are putting 1 as a 1. If it is 0, then we can write here 0. Now what happened? We can using the modulo 2 operation from MSB to the next MSB. Okay. So what is the next MSB here? Is 0. So 1 modulo 2 0. That means what? 1 modulo 2 0 is 1. See here. 1 modulo 2 0 is 1. So here we are getting 1. Next what happens? 0 modulo 2 1. Oh, also 0 modulo 2 1 is also 1. Okay, so here we are getting 1. And after that what happened? 1 modulo 2 0. 1 modulo 2 0 means what? It is also 1. So here we are writing here 1. So this for this particular binary code, the corresponding gray code is this one. Okay. So we can consider next one. This one. So MSB is same. So it is 0, 0, 0 plus 0 modulo 2 1 is 1, 1 modulo 2 1 is 0, 1 modulo 2 0 is 1, 0 modulo 2 1 is 1, 1 modulo 2 0 is 1, 0 modulo 2 1 is 1, and 1 modulo 2 0 is 1. So what happened for this particular binary code? This is the corresponding gray code. It is very simple. It is clear, all of you?
Yes, sir.
Okay. So this is the process to converting binary code conversion, binary to gray code conversion. Okay. Next one, see here how we are converting gray to binary code conversion. Oh, okay, just opposite. If you have a gray code, then how you are converting to the binary code. So this is the rule we have to follow. So what happened here? The first binary bit and the gray bit are same. When particular binary position and gray position, the first means what? What about the position of I, and what about the position of gray code? Okay. When BI equal to GI, that means what? If this particular condition is fulfilled. What is this condition? If number of ones preceding GI is even. Number of ones preceding GI. Okay. We are converting to the gray to binary code, remember? So preceding GI is even. And the next particular expression, see, BI equal to G dash I. G dash I means what? Here I want to say that this one is the complement form. GI is the complement of BI. So here I am writing a small complement symbol here, this one. Okay. So when this particular condition is satisfied, if number of ones preceding GI is odd. So if this particular two conditions, that means based on this particular two condition, we are converting gray to binary code. Okay. Just see this particular example. Gray code means what? Suppose 1010. Now we are interested to this particular gray code to the binary code. Then what we will do? So what happened? See here, the first one is 1. So there are no other MSB are there. So what happened? We can just, we don't know it is the even or odd. So by default, we can consider this one is even. So what happened? We are BI equal to GI means what? What is the BI here? No, GI is 1. So here also it is 1. Now we are going to the next bit of gray code, because gray codes is already given and we are converting to the binary code. So next one is what? 0. So before 0, how many ones are occurred? Even or odd? So it is odd. So what happened? When it is odd, that time complement of BI. So what is the logic value of 0? 0 is the gray code logic value is 0. So we are going to complement. So 0 goes to 1. Now what happened? Again we are going to the next MSB. Next MSB means what? This one is 1. And how many ones are occurred? How many numbers of ones are occurred? Only 1. So 1 means what? This is odd. So again we are complementing 1 to 0. So this one is the complement form of this one. Now what happened? Next one is what? 0. But happen, see here, the precedings, how many numbers of ones? 2 numbers of ones are already occurred. This one and this one. So numbers are even. So when numbers are even, then what happened? What about a gray code we can insert to the binary code? We are assigning to the binary code. Now what happened? 0 we are directly assigning to the binary code. Okay. And see here, this one also same. You can apply this particular two condition, and this one automatically this particular binary code is generated. Because gray code is already given to you. Okay, when you are converting gray to binary code. So what happens? Just you can check this particular, if any doubt, then please ask me. Is just check second particular example. Gray code is already given 0, 1, 0, 1, 1, 0, 0, 1. So the corresponding binary code is 0, 1, 1, 0, 1, 1, 0. So is it correct now? This one, you are getting? Any doubt this one? See here?
Yes, sir.
Yes, please ask me.
Yes, sir. बता दीजिए ये वाला.
Second one you are getting now. Second one you are getting or not?
No, sir.
No, sir.
See here. So what happened? The gray code is zero. The gray code is 0. Okay. So what happened before 0? Because this one is the most MSB, most significant bits. Okay. Before 0, there is no 1 or no 0. So that time what happened? By default, we are considering GI. We are assigning to the BI. Now, what is the value of GI? GI means what? Suppose this one is 0, 1, 2, 3, 4, 5, 6, 7. Here, G7 value is 0. So what happened here also? What happened? BI equal to GI. BI equal to GI means what? This one is also what? B7. Okay. So here we are writing 0, 0 to 0. We are writing in same manner. 0, 0 to just we are copy this one. Okay. Okay. Now next one is, see here. This one is 1. This one is 1. This particular one. So 1. How many number of ones are occurred? No, there is no. We cannot consider even or odd. So that time what happened? Just we are writing same BI equal to GI. So what happened? 1 moving to this here. 1. Next one is what? Next MSB bit is 0. So what happened? 0. How many ones are occurred? Only 1. Left hand side, see here, only 1 is occurred. Now 1 means what? Odd. So what happened? Whatever 0 is occurred in gray code, it is just complement. We are assigning as a complement of the binary code. So what is the complement of 0? 0 complement is 1. So here we are writing as a 1. Now what happened? We are going to the next MSB bit. This one is 1. Okay, this one is 1. Okay. So how many ones are there? This is also odd. Only 1 ones are occurred. So what happened? What is the complement of 1? Complement of 1 is 0. So here we are writing 1 to 0. Next one is what? 1. So how many number of ones are occurred? Even. So what happened? We are writing as it is. This one is 1 and also this one is 1. We don't require complement. Now when we are going this particular 0, okay, that time how many ones are occurred? 1, 2, 3. Okay, so 3 is what? Odd. So we are converting 0 to the 1 complement form. So it is going 0 to 1 complement form. Now when we are going 0, how many ones are occurred? 1, 2, 3. This is the odd. So what happened? 0 moves to the, or 0 compute to the 1's complement form. So this one is 1. Or we are, this is the complement
Yes,
form.
sir.
0 to 1. So now when we are going to this particular one, how many ones are occurred? 1, 2, 3. This is also odd. If it is odd, that time what happened? BI equal to G complement. So what is the G complement? G complement of BI is, this one is 1. Now its complement form is 0. So this way we are converting gray to binary code. Now you are getting?
Yes, sir.
Yes, sir.
Now you are getting?
Yes, sir. Yes, sir.
Now see here, why the main concept is what? Why when we are using the gray code, why gray code, the reducing, why gray code is capable to reduce in error conversion? Actually what happened when we are using the gray code, that time what happened? Gray code generally we are using to reduce the errors. Okay. Suppose what happens, see here. So when it is 0, 0, this is white. Only two colors we are using. One is called white and one is called black. So black we are representing as a, suppose we are representing as a, suppose representing as a 1. Suppose logic 1, and 0 color we are representing as a 0. Okay, suppose. So what happened? There are different type of sequence are there. If we are considering this particular portion, if we are considering only this particular portion, that time what happened? It is all are 0 because all are white portion. All are suppose 0, 0, 0. How many portions are there? The number of zeros are occurred. How many portions are there? Suppose this one is portion, this one is portion, this one is. So four number of zeros are occurred. But when we are moving this particular portion, that time what happened? The last bit is Now last portion is black. So here we are writing 0, 0, 0, and 1. This way we are, if we are going this particular portion, the first two portion is white and next two portion is black. So here we are writing 0, 0, 1, 1. So this way, see here, in this, when we are considering this particular portion, that time what happened? Maybe it is step 3. So what happened? The binary codes are generated 0, 0, 1, 0. Because first two portion are white, the third portion is black, and fourth portion is again white. So third position is black, so it is coming as a 1. Okay. So I'm just giving the what is the meaning of this particular picture. After that, I am discussing detail. So the same thing what happened if we are considering 0, 0, that time what happened? This particular portion is all are white. Now see, when we are writing binary code, okay, or you can consider binary coded decimal, or you can consider, suppose what happened, we are writing BCD form. We are writing suppose BCD form, and suppose we are using 4 bits. Okay, that time what happened? See here, if we are going, suppose we are considering the decimal value is 7. Okay, if you are considering the decimal value is 7, decimal value is 7, that time what happened? What is the, if we are writing in the BCD format, that time what happened? And if we are using the 4 digit, that time what happened? What is the sequence, binary sequence? 0, 1, 1, 1. Yes or no? And when we are 8, BCD is 8, that means decimal value is 8, that time what happened? We are writing 1, 0, 0, 0. 1, 0, 0. So meaning is that when you are comparing this particular two binary sequence, this one and this one, that time see here, all the bits are changes. How? 0 is changes to 1, again 1 is changes to 0, next one is changes to 0, and next one is changes to 0. When we are writing in 8421 weighted code word, or when we are writing normal binary sequence, and when we are writing in BCD, that time what happened? When we are writing in the 7 in binary sequence or 8 in binary sequence, that time what happened? When we are comparing both the binary sequence, all the bits are changes. But what happened? When we are using the gray code, only one bit is changes. Because what happened earlier, we are discussing the what is the definition of gray code? Only one bit position is different. Okay. So what happened? Sometimes what happened? If some particular cases what happened? How it is reduce the error? Suppose what happened? Many bits position are changes. Okay. So due to some particular error, 1 goes to 0 and 0 goes to 1, there many bit positions are changes. Okay, that time what happened? We are not going to scan all the bits. Okay, whenever only one bit position is different, that time what happened? Automatically we understand that there are some particular errors are there. Okay, so we are not scanning all the bits one by one, because what happened when we are using the gray code, the properties of gray codes allow us to check only one bit position is different. Okay, based on that particular properties, we can easily check. That means some particular, we can reduce the errors. Okay, so what happened? So here the last line I'm just saying, this one is says that the but in the gray code, error can only be in single bit during the readout. Okay, you can check 7 and 8. Okay, when we are suppose this one, when we are writing 7 and 8, that time what happened? This one is 0, 1, 0, 0. Okay, and binary code, this one is what? This one is 1, 0, 0. Okay, sorry, this one is not this one. This one is the 8 gray code, and this one is 7 gray code. So what happens, see here, all the 3 bits, next MSB 3 bits, this particular portion is 1000, this particular portion is also 100. But what happens, this particular 1 bit is changes only. Here it is 1 in 8, and in 7 this one is 0. So if you are considering any particular sequence number of binary bits or gray bits, gray codes, that time what happens, only 1 bit is different. So this way what happens, we can say that when we are using the gray code helps to reduce the errors. Okay. So this is about the gray code. Any doubt up to this one? Any doubt?
No, sir.
No, sir.
No, sir.
So we are going to the some particular different slide. There are some other bits. This is also is a non-weight. Access tree is called a non-weighted. No, yes, access tree is called a non-weighted BCD code. Because why it is called a BCD code, non-weighted BCD code? Because what happens, we can go the concept based on the BCD, this particular BCD. Okay. And the next point is, see here, the code is derives, is binary code word is the corresponding 8421. We can, when we are writing the access tree, we can follow the rule of BCD code. So what is the weight of BCD code? BCD code weight is 8421. Okay. So when we are writing in 8421, after that what happens, we are adding +3. Okay. So whatever we are getting, if we are writing in the BCD in the binary sequence form, then that particular bit is called access tree. हेलो हाँ हाँ भैया, अच्छा मेरा एक क्लास चल रहा है, मैं थोड़ा देर के बाद आपको फोन कर रहा हूँ. हाँ okay. And sequentially, when we are writing, it is sequential code, therefore it is can be used for arithmetic operation. So it is not like that we are not maintaining any, and the gray code also we are maintaining some particular sequence. Okay. And here also when we are writing the access tree code, this is also called a sequential code. Okay, we are maintaining some particular sequence. See here, suppose this one is the decimal digit. In this particular table, these all are the called decimal digit, and this is the binary conversion. Suppose decimal binary range is 0 to 9. So here I am writing the decimal range is 0 to 9. When we are converting in the BCD form or 8421 form, then this one is 0400, 140001, 240010, and 340011. Because when we are writing in the BCD format or 8421 format, only 4 bits are required. Okay. So in every bit sequence, we are using 4 bits. Okay. So 4 is 0100, 5 is 0101. Okay. And 6 is 0110, 7 is 0111, 8 is 100, and 9 is 1001. So how we are converting the access tree? It is very easy. We are adding +3. We are adding what? +3. So if we are using +3, that time what happens? It is converting to the 0011. So what is the 0011? 00 in decimal form, this is 3. And this one is 1. 1 plus 3 means what? 4. So this one is what? This one is 4. I am talking about this one only. Now this one is 2. So what happens? 2 plus 3, it is 5. So this one is 5. This one is what? 3. 3 plus 3 is 6. So this one is 6. This way, we are generating the access tree code. So see here, last one, it is 1001. 1001 means what? 9. 9 plus 3, 9, 10, 11, 12. So this one is representing as a 12. Any doubt this one?
No, sir. No, sir.
So this one is called a access tree code. Now what happened? It is maintaining the sequential code. So this particular access tree code also we can use for arithmetic operation. So how we can use the arithmetic operation? So when we are considering the access tree for addition, this particular addition, you can follow this particular three rules. This particular three rules. You can check one by one. To add in access tree, add the access, and also remember access tree also we are writing in this particular format, short form, XS3. Okay. So when add the X3 number by adding 4-bit groups in each column starting from LST. If there is no carry out from the addition of any 4-bit groups, subtract 0011 from the sum terms of this group. Otherwise, if the carry is generated, that time what happens? We can add. Here we can subtract. Here we can subtract. If no carry is generated, but when carry is generated, we can add 001 to the sum terms of this group. So this way we can complete the process of addition. Now it is your duty. I am giving one particular homework, and the next class I am asking this one. Why 0011 we are using? Why we are not using any other binary sequence? Why we are using only 0011?
3.
And why if carry is not generated, why we can subtract 0011? And when then why we are adding 0011 when the carry is generated? So you can read out the whole book. Book is already given. So next class, I am asking any particular student, X, Y, Z, any student, then you can answer me this one. So why we are adding and why we are subtracting, and why we are using only 0011. Why we are not using any 4-bit binary combination. Okay, that particular part, it is considered as a homework, and next class I am asking. Okay, now what when based on this particular three condition, I will explain with this particular example. Suppose 5 3. So how we are writing 5? 5 we are writing in BCD from at first we are writing in the BCD from. BCD from is what? We are writing in 5. Okay, 5 means what? 5 plus 3. So 5 plus 3 means what? It is 8. Yes or no? 8 we are representing as a. Oh no. Just a minute. 3. Just here. What is the problem? So 5. Okay. When we are converting to the access tree, 5 plus 3 means what? 8. So here we are writing 100. And this one is 3. And 3 which added with 3. So 3 plus 3 means what? 6. So we are writing 0100. So when we are adding, that time what happens? See here, no carry is generated. If no carry is generated, that time what happens? We can subtract 0011. And also don't use this particular subtract. You can convert minus 3, this because 0011 it is converting, when we are converting to the decimal number, that time it is representing as a 3. So this one you can complement. If you are complementing this one and adding, that time same result is coming. Just I am subtracting here, but you have any problem with subtraction, then you can use the complement. So this particular result is coming. Okay, so what happened? If we are doing the 5 plus 3, 5 plus 3 is normally is what? 8. 8 we are getting. If normal decimal addition. When we are adding 8 plus 3, when we are converting to the excess 3, 8 plus 3 means what? 11. Okay, we are getting 111. And this one also we are getting as the result is 111. This particular binary sequence representing as a 111. Because what happens, see here, 0, 1, 2, 3, 8 plus 2, 10 plus 1 is 11. So this is the correct sum in excess 3 form. This one is the excess 3. Now next one is C. We can converting 3 plus 3 means what? It is 0, 1, 1, 0. And this particular 7 plus 3 means what? It is 10. So 10 we are representing as a 1, 0, 1, 0. And 2 is what? 2 plus 3 means 5. So here we are representing 0, 1, 0, 1. And 8 we are representing 8 plus 3 is 11. So here we are representing as a 1, 0, 1. So when we are adding, that time what happened? The earlier method in BCD, when carry is generated, that means what? This particular carry we are adding to the next group. After that we are getting this one, 1, 0, 0 and 0, 1, 0, 1. So see here carry is generated. If carry is generated, that time what happened? We can add. So here we are adding 0, 0, 1, 1. But here see, in this particular one, no carry is generated. So we can subtract 0, 0, 0, 1, 1. Okay. So based on this, we are getting this one. 1, 0, 0, 1 and 1, 0, 0. You can add 28, 37 plus 28, how much? 37 plus 28 is 65. So if we are using the 65 here, so 6 plus 3 means what? It is 9. And 5 plus 3 means what? This one is 8. So this one is the excess 3 form. Okay, any doubt this one?
No, sir.
All of you getting?
Yes, sir.
Okay. So next one is what? This one is the subtraction. Excess 3 arithmetic subtraction. Earlier we are discussing addition. Now this one is called a subtraction. To subtract in XX3, the number subtracting is 4-bit group from the LSB. This one is the same in addition also, subtraction also. And after that, now what happen? If there is no borrow, that time what happen? We can add 0, 1, 1. And if it is borrow, then subtract 0, 1. So again, I'm one question to you. Just you can read out, and next class you tell me why we are, when no borrow is generated, then why we are at 0, 0, 1, 0, 0, 1, 1. And when there is a borrow is generated, why we are subtracting 0, 1, 1. And why we are using only 0, 0, 1. Why we are not using any binary, any other 4-bit sequence. Okay. So this one is very simple, 2, 6, 7. So what is the excess 3 of 2? 2 plus 3 is 5, so this one is 5. 6 plus 3 is 9, so this one is 9. And 7 plus 3 is 10, so this one is 10. And next one is what? 1. Okay. So 1 plus 3 means what? This is 4. Okay. And 7 is what? 7 plus 3 is 10, so this one is 10. And 5 plus 3 is 8, so this one is 10. I am doing this subtraction here, subtract, because I am writing here minus. So you can you can convert this particular complement form, and you are adding this one. Then that time what happens? Same result you are getting. Okay, I am getting this particular one, and see here when we are subtracting 0 minus 0, this one is 0, 1 minus 0, this one is 1, 0 minus 0, this one is 0, and 1 minus 1 is 0. So there is no borrow is generated. When no borrow is generated, that time what happens? No, we can add 0, we can add 0, 0, 1, 1. So here we are adding 0, 0, 0, 1. Now see here, this one is 1, 0, 1, 0 is 1, 0, 1, this one is 1. Okay, borrow is 1. So what happened? 0 minus 1 is 1. Again, what happened here? It is 1. 1 minus 1 is 0 and 0 minus 1 means what? 1. And 1 extra bit is generated. Sorry, borrow bit is generated. So when borrow bit is, when there is a borrow, that time what happen? We can subtract 0011. So here we are using the subtract minus 0011. Now see here, 1 minus 0 is 0. This one 1 minus 0 is 0, 0. 0 minus 0 is 0. This one is 0. And 1 minus 1 is 0. And 0 minus 0 is, this one is 0. Okay, so there is no borrow is generated. If there is no borrow is generated, that time what happen? We can add 0, 1, 1. So here we are adding plus 0, 0, 1, 1. Okay, when we are adding, we are getting this one. When we are subtracting, we are getting this one. And when we are adding, we are getting this one. So what happened? What is the, if we are 267, what? So how much we are getting? 92. We are getting, so this one is, no. We are getting 92. No. 267, no. 267 minus 174. 92.
सर
Yes.
सर वो जो पहले वाले में 000 आया और कोई बोरो जनरेट नहीं हुआ तो हमने प्लस क्यों किया? वो तो 000 तो 0 ही रिप्रेजेंट करेगा ना।
किसमें? इसमें ना ये पर्टिकुलर एग्जांपल के लिए बोल रहा है। इसके लिए ना पहले वाला।
इसके लिए एकदम सबसे आगे तो 0 4 0 आया ना।
हाँ 4 0 आया।
और वो तो 0 ही रिप्रेजेंट करेगा, उसके साथ भी प्लस करना पड़ेगा क्या?
नहीं, इसमें 0 रिप्रेजेंट नहीं कर रहा है। ये जो हम लोग का यहाँ पे एमएसबी कौन सा है? एमएसबी ये 1 है। ठीक है, मेरा मार्कर तुमको दिखाई दे रहा है ना?
हाँ दिखाई दे रहा है।
हाँ, तो उसके ऊपर में मैं क्या लिखा? 1 लिखा।
बोरो 1
ये बोरो हो गया। ये लास्ट बिट के लिए तुम्हारा बोरो ऑलरेडी जनरेट हो गया ना?
हाँ हो गया।
जब बोरो जनरेट हो गया तो इसमें क्या लिखा है? इफ देयर इज ए बोरो देन सब्सट्रैक्ट 001 तो यहाँ पे इसीलिए मैं यहाँ पे सब्सट्रैक्ट किया माइनस 0011।
हाँ ये समझा सर। द मोस्ट सिग्निफिकेंट आंसर का जो मोस्ट सिग्निफिकेंट बिट है 0000
हाँ
उसके साथ प्लस क्यों किया? वो तो इन जनरल 0 रिप्रेजेंट करेगा ना, उसके साथ प्लस करना जरूरी है।
कौन सा? ये जो नहीं जस्ट
हाँ ये जो मार्कर है।
हाँ ये जो तुम बोल रहे हो ये 0।
हाँ इसके नहीं, ये पूरा के साथ 0000।
हाँ 000 ये पूरा के साथ।
हाँ तो प्लस करना जरूरी है क्या? वो तो 0 रिप्रेजेंट कर रहा है ना।
नहीं, उसमें वो तो बोल नहीं रहा है ना। इसमें ये देखो, इसमें क्या हो रहा है? इसमें तुम्हारा माइनस हो रहा है। हम लोग क्या कर रहे हैं? 267 माइनस 175।
हाँ
ठीक है, ये हम लोगों ने क्या किया? 2 और ये 2 है। 2 प्लस 3 क्या है? ये 0101 है। ठीक है, 1 क्या है? 1 के प्लस 3 है तो ये 4 हो गया। ठीक है, रुको एक मिनट, ये हो गया। तो इसमें हम लोग क्या कर रहे हैं? अभी माइनस कर रहे हैं। ये पोर्शन जो है, ये पोर्शन और ये पोर्शन हम लोग माइनस कर रहे हैं। ठीक है, क्योंकि बोरो तभी जनरेट होगा जब हम लोग माइनस करेंगे। ठीक है, हम लोग अभी एड का टर्म यूज नहीं करेंगे क्योंकि हम लोग एडिंग नहीं कर रहे हैं, सब्सट्रैक्ट कर रहे हैं। जब भी सब्सट्रैक्ट करेंगे तभी बोरो का टर्म जनरेट होगा। जब इसको मैंने सब्सट्रैक्ट किया तो देखो इसमें सब में 0 आया। ठीक है, इसका जो रिजल्ट है इसमें भी 0 आया, इसमें भी 0 आया, इसमें भी 0 आया, इसमें भी 0 आया। तो इसमें क्या हो रहा है? बोरो जनरेट हो रहा है
ना, क्योंकि वो
ना
तो
बोरो। हाँ, तो सेकंड पॉइंट, ये जो पॉइंट हम लोगों ने लिखा है ये वाला, क्या लिखा है? अगर देयर इज ए नो बोरो देन एड 0011। ये देख रहे हो? एड 00। तो इसीलिए हम लोगों ने यहाँ पे ऐड किया। कौन सा ऐड किया? 0011 को ऐड किया। ठीक है, इसमें बोरो जनरेट हो रहा है, इस वाला में बोरो जनरेट हो रहा है। तो जब बोरो जनरेट होगा if there is a borrow then क्या माइनस, तो इसीलिए हम लोग
0 0 1 1
1 को माइनस किया। इसमें बोरो जनरेट नहीं हो रहा है, इसमें इस पर्टिकुलर पोर्शन में, तो जब बोरो जनरेट नहीं हो रहा है तो क्या करेंगे हम लोग, ऐड करेंगे। क्या ऐड करेंगे, प्लस। तो इसलिए हम लोगों ने इसको 001 को प्लस किया, ठीक है। उसके बाद प्लस करने के बाद हम लोग क्या करेंगे, ये पोर्शन को प्लस करेंगे, ये माइनस है तो इस पोर्शन को माइनस करेंगे, और ये प्लस है तो इस पोर्शन को प्लस करेंगे। तो हम लोग क्या आया, 0011 1100 एंड 010। एक मिनट,
जीरो 912
सर।
जीरो
यस
सर वो पहले वाले में 1 माइनस 0 0 कैसे हो गया?
कौन सा 1 माइनस 00 हो गया?
सर वो जो है ना 0101 माइनस 0100
हाँ
MSB, वो मतलब 0000 कैसे होगा सर? 1 माइनस 0 0 है यहाँ पर।
ठीक है, ठीक है। अरे आवाज तो ठीक है कि नहीं है?
ठीक है सर, ठीक है सर, ये वाला। यस सर, यस सर।
थोड़ा मैं ठीक से लिख नहीं पा रहा हूँ इसको, थोड़ा ये हो रहा है, ये माइनस है, हाँ दिस वन इज माइनस, और 0 माइनस, ये 0 माइनस 0 ऑलरेडी, सो इसमें क्या आएगा, सब में क्या आएगा आपका 0 आएगा, ठीक है ना?
यस सर।
So this one is called a BCD ना, ये excess tree, this one we are getting the excess tree। अगर इसमें अगर कुछ डाउट है तो आप लोग देख सकते हैं, देखने के बाद आप एग्जांपल कीजिए, एग्जांपल का कॉन्सेप्ट तो आप लोगों को समझ में आ गया। सो वी आर यूजिंग दिस पर्टिकुलर थ्री कंडीशन, दिस वन एंड दिस वन, ठीक है। ये करने के बाद आपको ये आएगा, हाँ ये थोड़ा एग्जांपल ट्राई कीजिए, इफ अगेन यू आर गेटिंग एनी डाउट देन यू कैन आस्क। Okay, yes, if any doubt, this one particular access tree, when you are doing the arithmetic of access tree, you can try yourself on the other examples. If again you are getting any doubt, then I'll explain this one. Okay, are you getting?
Yes sir.
Okay sir।
Okay, then I'll close this particular session. So one by one, just you can leave this particular method. Okay, next class I will consider. Now I will take on 15 of September, Tuesday. Okay.
Thank you sir।
Thank you.
Thank you sir। Thank you sir।
Thank you.
Thank you sir।
Sir. Thank you, sir.
Thank you.
Thank you, sir.